Well, good evening again, everyone. I hope you're not going stir crazy or will be going stir crazy. Seems like we're going to be out of school for the next couple days, so make sure you watch the videos. You will have homework. Okay, we're going to look at the last property of logarithms and then the change of base formula. The last property of logarithms is called the inverse property. So the inverse properties of logs, I'll just abbreviate logarithms as logs, and exponents. And you'll find this property on page 514. The property says this here. It says that log base b of b raised to the x is equal to x. Okay. And it also says that b raised to log base b of x equals x. You know, of all the properties that we learn in 7.4, these are perhaps the most important. And these are the ones which we're going to use as we move ahead because they help us solve equations. And Algebra 2 is all about solving equations. Alright, so let's explore this. And I'll give a graphical view of what's happening here. So let's say here I have, just as an example, let's say here I have log base 2 of 2 raised to the 5th. Now let's just take a look at function mapping here. Okay, so let's say my input x will be 5. So that's my 5 there. And then I have some function, and that function is going to be 2 raised to the x. Okay, so 2 to the 5th, so 2 to the 5th is going to be 32. And that's the function I have there. Okay. Now, what makes inverse functions nice is that if I apply the inverse function, I can get back to where I started from, or I can get back to x. So if I go from 5, if I start with 5 and get 32, it would be nice to now with 32 get back to 5, and that's what inverse functions allow us to do. So the inverse function then, f inverse, that's going to be log base 2 of x. Okay, so log base 2 of 32, again, now this is x. Well, this was, so that was y, and again, remember you switch the x and y, so now this becomes x. Let me put this down here, and now this will be y. Okay, you switch x and y's, but log base 32 is equal to 5. So that's nice. See, I got back where I started from. Okay, I started with 5, and y I got was 32. Okay, now given 32, I can get back to 5. Okay, and that's what make inverse functions nice, and that's what we're going to use a lot when we solve equations involving logarithms and exponents. Without it, we would not be able to solve them. So let's just go over some examples. So log, so here's an example, log base 8 of 8 raised to the 3x plus 1. Well, that's just going to equal 3x plus 1. Okay, so that's what the inverse property says here. So that was x, x. So this is 3x plus 1, 3x plus 1. Okay, likewise, log base, see here, 5 of 125, I can write that log base 5 of 5 to the 3rd. My bases are the same, and so that's just going to equal 3. Alright. Now, if you remember from the lesson previously, I could have just as well have written as, I could have brought down the 3, and that would have been then 3 times log base 5 of 5, which would be 3 times 1 equals 3. So you see everything, it all works out. It all works out. And then lastly, well, let me put that back. And then lastly, maybe if I just did another problem, if I had log base 1/2 of 1/2 raised to the minus 4. Okay, so my bases are the same, and so that's just going to equal negative 4. All right, so pretty easy property to understand. Inverse property is also one of the most important. Okay, and then now so we were working with this property here, and now we'll work with the exponent side. So that there. So let me erase some of this because it's going to be nice to keep that in view. And then we'll work with exponents. And again, I'll do a function map to show you that it works as well. Okay. So let's see here. I think I've cleared. Well, let me get rid of that. Okay. So here. So for example. So let's say here I have. So I have, just as an example, my base is 2, and I'm going to raise that to log base 2 of 8. All right. Now, function map here. This is my x. I have some function, and that function is going to be y is equal to log base 2 of x. So I'm going to start with 8. I'll start with 8. And log base 2 of 8, well, that will give me 3. Okay, and like before, so now my y's become my x, and x becomes y, and now my inverse function will be 2 raised to the x. All right, and so 2 to the third gives me 8. See, again, I got back to where I started from. Okay, I started with 8. Okay, and then I got 3 as my output. I took my output that became the input to this function there, and I get back to 8. Okay, so that's nice. So there's the property that if you take a base and raise it to a log with the same base of x, you get right back where you started from. You get x. So for example, 2 raised to log base 2 of 27, or 7, let's just keep it 7. Well, that's just going to equal 7. Okay, and maybe as another one, 2 raised to log base 2 of 3x. Well, that will just equal 3x. All right. Very easy properties to understand, but perhaps the most important in the entire chapter, particularly when we get to solving exponential and logarithm functions. Without the inverse property, we would not be able to do that, so keep that in mind. Now, the last thing that we have to learn is called the change of base formula, and it's not a property, but it's just a method that we can actually use to solve logarithms when we really don't know how to, basically is what that means. So, and the change of base formula, it goes like this. So I have a log and to some base of x, and that just equals log base 10 of x over log base 10 of b. So again, if you remember from the last lesson, when you don't see a base, you assume it's 10. Now, I could have just as well have written it this way, log base 10 of x over log base 10 of b. Okay, but we generally ignore the 10 when we're working with base 10. So let me just get rid of that. All right, so we'll see how that is helpful. So for example, let's say here I have log base 3 of 7. Now 3 raised to what is 7? Well, it beats me. I have no idea. Okay, but we can just use the change of base formula. We can change it to base 10, and we'll be able to evaluate this. So this would equal log base 10 of 7 over log base 10 of 3. And again, we're working with common bases here. So let's just evaluate that with the calculator. Log of 7 over log of 3. Okay, so log of 7 divided by log of 3. Oops. Try that again. Log of 7 divided by log of 3. Okay, so that's 1.712, yada yada yada. Alright, so let's look at 1.712. So this is going to equal 1.712 something. Let me just go back to that. 1.7712. 1.7712. Something, something, something. Alright? So, so that's what we use when we don't know how to evaluate a log. And I just want to check something. Yep. So for example, so then 3 raised to the 1.7712, yada yada yada. Well, that will give me approximately 7. All right. So it works. Change of base formula, very easy to understand. That log base b of x is equal to log base 10 of x over log base 10 of b. Very easy to do. And we can evaluate something like this just as a final example. Let's see here, we had log base 9 of 27. So 9 raised to what is 27? Don't know, so let's just use change of base. That would be log base 10 of 27 over log base 10 of 9. Let's use our calculator and see what that is. So 27 and 9. So log base 10 of 27 divided by log base 10 of 9. And, oh, that's 1.5. So that would be 1.5. So 9 raised to 1.5, that will equal 27. Let's just verify that. So 9 raised to the 1.5. 27. All right. So there. And, let's just see here. Yeah. Okay, so with that then, you guys will have some problems to do. Using the change of base formula is pretty easy to do. And again, the most important property of 7.4 is the inverse property of logarithms. So I'll post some exercises for you guys to do.